Example 11.6. What is the temperature of the steel copper junction in the steady state of the system shown in figure? Length of the steel rod, that is 15 centimeter. Length of the copper rod, that is 10 centimeter. Temperature of the furnace, that is 300 degrees Celsius, and temperature of the other end, that is 0 degrees Celsius. The area of cross section of the steel rod is twice that of the copper rod. Thermal conductivity of steel, that is 50.2 joule per second meter Kelvin, and of copper, that is 385 joule per second meter Kelvin. Now see here, the composite system is given to you. Here steel rod, and at the end of steel rod copper rod is joined. Now one end of the steel rod, that is in contact with the furnace, which one is at 300 degrees Celsius, and one end of the copper rod, that is in contact with the ice box, which one is at 0 degrees Celsius. Now here we can understand this thing, the heat current will flow from steel to copper. Now length of steel rod 15 centimeter, so that is 0.15 meter. Length of copper rod 10 centimeter, so that is 0.10 meter. Area of cross section for steel rod, that is 2 times area of copper. Then thermal conductivity of steel and copper, both are given to you. Now we already derived the equation for the heat current through the conducting rod, that is H equal to K A T1 minus T2 upon L. Okay. Now here see, heat current have only one path to flow. So this is just like a series combination. Okay. So when only one path is there to flow, it implies that the current through both the conductors will be same one. So here we can write one equation for heat current for steel rod, that is H equal to K steel, area steel, and suppose the temperature of the furnace is termed as T1 and temperature at the junction of steel and copper, that is termed as T0, then we can write T1 minus T0, that is the temperature difference upon length of steel rod. But the same amount of heat current is flowing through the copper rod also. So we can write that H equal to KCU ACU into the temperature difference between two ends of the copper rod. So one end that is at temperature T0, other one that is in ice box. So say it is temperature T2. So we can write T0 minus T2 upon length of copper. Clear to all of you? Now Ks, area of steel, that is 2 times area of copper. So area of steel is replaced by 2 ACU. T1 minus T0 upon LS, that is equal to KCU ACU into T0 minus T2 upon LCU. Now substitute the values. K steel 50.2. These two as it is. Area CU cancel from both the side. T1, that is the temperature of the furnace given to you, 300. Minus T0, that is the temperature of the junction that we want to find. Upon length steel, that is 0.15. Thermal conductivity of copper given to you, 385. Then T0. T2, temperature of ice box, that is 0 degrees Celsius upon LCU 0.1. Now solve this equation and make T0 is the subject, you will get the temperature at the junction. Clear to all of you?